Assalamualaikum warahmatullahi wabarakatuh. We beat to your daughter. So we right now we are going to present you about the finite automata in theory of computer science. So next. So this is our team member. So first is me, Fikri, and then we have Faiq, Danial, Amir, and Aidiel. So for the next is what is finite automata? So finite automata is in a simpler term is a simplest form of machine to recognize one pattern. So if we separate it, so it can be a collection of three main things. For first one is a finite state of set of state. So and one of them will be start and in it or we call it initial state, and some or maybe none in certain thing will be a final state. So the next one is the alphabet, uh, kind of like letter E. So of it means that it is a possible input letter. So the last part is a set of transition table. So this means that it tells for each state of for what input and which state to go. So here we can see the example picture of a finite state. So here we can see that the initial or start state is Q1 and the final or accepting state is Q2. So and there are some input for each state, and the it will show where the state will change after getting the input. So for the next part, I will pass it to uh, Aidiel, if I'm not mistaken.
So FA can be categorized into two types, which is DFA and also NFA. So I'm going to explain a little bit about the LDFA. So DFA is an acronym that stands for Deterministic Finite Acceptor. So DFA is finite state machine that accepts or rejects a certain string or symbols by passing through a string determined data sequence. So the string might be like 1010 or maybe AB or something like that. So that's a little bit difference between FA and FA. So where's the picture? Okay, so this is the example of a DFA. If we can recognize this is a DFA by look at the state. So you look at the state A. So there is an output arrow which read the string one, and also there it also has the output arrow which read output which read the number zero. So every state must have the two states. So for NFA, I pass it to Daniel.
Okay, so for the NFA is actually a non-deterministic finite automata. It is easy to construct than the DFA for given the regular language. So in NFA, when there exists many paths for specific input from the current state to the next state, and the NFA is not every NFA is DFA, but each NFA can be translated into DFA. So the NFA function are like DFA, except that it contains multiple next state and it has a epsilon transition. So the NFA can be understood as multiple little machines computing at the same time. So here is the example. As you can see, there's the state where Q is the finite of set of states, and then the finite set of input symbol. Q0 is the initial state, F is the final state, and then the transition function. Okay, so next one, we will talk about the application.
Okay, for the application in the automata for in machine for automata, the first is KD write. We can see this at the shopping mall or any shopping complex. So for the KD write, we can say that the starting state is when the people or the kid has insert the coin or not that need as a input process, and then the next state will be push the start button, and after the start button is being pushed, the next state will start to occur where the kiddie right start to move, and after a certain period of time, the kiddie right will stop, which is the final state where the kiddie right will be back to the idle idle states. So for the in the future, let's say for more improvement, the kiddie right can be the coin or not can be replaced by touch and go. The time limit, we can set the time limit for the kiddie right, and also we can use auto saving power, which will not operate when there is no people around. And the next application I will pass to Faiq.
Okay, so for the next application is leaf. So for the leaf application, we have three state, which is the starting state. So when the starting state, when the human press the button, when before entering the leaf is idle. So that is the starting state for the leaf. And for the next state, when the human push the leaf level button, it will go to the leaf will start to move. So when the leaf will start to move, and after the leaf arrive to the level that the human press the button, so the leaf will become ideal, which the final state is the starting state, which is the same where the leaf will become ideal. So I think that's all from us. Thank you.